Hello my friends, welcome to 2021. I thought I'd start the year with the continuation of our Maya expressions tutorials. So this is 07. So what we've done on expressions is that we've figured out how to do conditions, how to handle variables, and then we've figured out how to create some randomness with random values and noise. In 07 we're going to deal with more structured and predictable waveforms, and these will help us do more useful things, as you will see. So these are sine and cosine functions that can give us something that look like this. So what's going on is that sine function is driving the rotate z, that swing this object in the z rotate axis. It's in a very predictable fashion. The back and forth motion is an oscillation in very predictable and very regular intervals. So in the same way, the same motion with the same function and the same parameters are driving the back and forth motion of the cube. This time around we're driving the translate, and if we take a look at the animation in the graph editor and I turn on show results and frame up, I'll be able to see that the curve that drives this animation is going positive and negative, and what we see here, true enough, it is going to the negative x-axis and the positive x, and the peaks are very regular, so are the valleys of the curve. Taking a look at the graph, the sine and cosine curves are part of a trigonometry functions that is related to the angles in the circle. As we plot our value in y, and as it travels along in x, you'll see a repeating pattern like that. In our case, the y is the value that it keeps updating and giving to whatever we drive our channels with, which is translate x, and then in the axis of x in relation to the function, it's time. So as time goes on and we keep giving it new updated frame numbers, the sine function curves gives us a repeating and updating graph like that. So what about the cosine? So the sine, when we give it 0, if I go to my frame 0, will always return me 0. I've extended my frame range to 0, and at frame 0 we see that the sine is 0. Okay, let's take a look at the expression for sine. Okay, the simplest expression for sine, I'm going to create a new cube here, and the way to do that will be open up your expression editor while selecting translate x. Because I'm already at p cube 13 and translate x, I can do tx is equals to sine, right, frame, which is my frame number, and that's the simplest form of the sine function. So if you create that, you will see that the channel now has purple color marking the channel, so that's controlled by our expression. And you'll see when you play, it will do the sine function. And if you see the graph editor, it's going from negative 0.9 and positive 0.9 and negative 0.9. So it's actually going from positive 1 to negative 1. So that is our default and the simplest form of the sine function. So it always gives you a positive 1 and a negative 1, as shown here as well. So positive 1 and negative 1. This is 1 unit, right? And this is another 1 unit. So the default sine function gives us an amplitude of 2. The next thing is the frequency, which is how frequently it repeats itself, come back on the same value. So that is our sine curve. Let's drive our y with the cosine function. We can address many attributes in one expression. So I'm going to use the same expression on x to include another line of expression that targets attribute y. So in Maya, each expression that you create is its own node in the node editor. Like for example, if I have translate y, and then if I say that translate y is equals to sine, right, frame again, you would see that just now it was expression 17. If I create, you'll see expression 18, so it's a new node unto itself. I'm going to delete that, go back to translate x, I'll see expression 17, and I'm going to say ty is equals to, because my default object is p cube 13, it still knows to connect the output of this expression to the attribute translate y. Ty is the short name of the attribute translate y. If I say cosine frame, okay, so this is sine and cosine in the simplest form. I edit, you'll see that another curve, which is the cosine curve, is now created. And you'll see that at frame 0, where the sine gives an output value of 0, cosine gives an output value of 1. Their amplitude and the timing is exactly the same. So you'll see that the relationship is always offset from each other, where cosine is 1 first, and then sine, which is the translate x curve, reaches 1.0 value later. The cosine reaches 1 again at frame 6, and then frame 8, so it's almost like 2 frames a delay. The sine function reaches 0.989. You will see some values being chipped off. That's because it's going too fast. The frame numbers, the 1.0 happens in between those frames, so we were not able to capture it. We would be able to capture it, however, if we stretch out the curve. And very interesting, when we put one of the x and y to sine and cosine in this manner, when we play, my cube actually does a perfect circle. It might be too small, a space from +1 to -1, to see this, and it's too quick. So what we're going to do now is to slow down, to stretch the curve out. We need to slow down the passing of time. I'm going to do a times 0.5, so that when it's frame 2, it's going to times 0.5, so it becomes 1. So the exact same thing, you can do a divide by 2, which gives exactly the same thing. So if we update the expression, you will see the curve is stretched out. If you don't like that, you can do a multiply by 0.33 on both. And you will see we're traveling in a much slower motion. Instead of y now, I want to do a z. Okay, and I'm going to zero out y now, so it rests on our home grid. That made it slower, didn't it? Because we're feeding a slower version of the actual frame that we're on into the sine and cosine function. So now it's +1 and -1. If we wanted to make it 5 times, that means it's going to go from +5 to -5. What we need to do is, taking that sine curve, after it's giving us that value, multiply it by 5. So all we need to do is times 5. When you update that expression, you will see that it goes in a larger circle. What can we observe here? We can see that slowly the form of our function becomes a little bit more complex, right? But you can understand that whatever's inside is the value we wanted to evaluate. That value is the x value, which is our passing of time, and then it gives us the y value, which is always +1, -1, and then we multiply it by 5, which is to further amplify it. Hence we have the multiply by 5, or whatever number that you require. So having this, you see that it travels a greater distance in the same amount of time. So whatever used to be comfortable for us to watch, right, in +1 and -1 space, is now travels too quickly and is very rushed, isn't it? So we want to further stretch out and slow down the passage of time. So 2.2. So every frame will feed into this function a smaller and slower passing of time. So I'm going to update that. Okay, now you will see it slower. So you see that from 0 to 120 frames, 1, 2, 3, it passes only 4 times. But now I'm going to slow it down even more, so I'll just see 2 cycles of that happening. So this sine curve describes a lot of phenomenon in nature. A lot of motion are complex combinations of these, of the cosine and the sine functions. So we are able to do quite natural looking things with our CG without manually keyframing, okay, because they are perfect curves and the arcs are perfect and all of that. I'm not saying to use sine and cosine functions to be lazy and get out of manually keyframing. Okay, there is a lot of value in manually able to direct the keyframes. So imagine you want to do a motion like that and then you try and key it by hand. It's gonna be a nightmare because you will never get, well, there are other better ways to do that, like creating a circular path and constraining the motion of the cube to the path, but not manually keyframing your channels like that. Okay, the sine and cosine, because of the trigonometry properties, where these two functions are derived, putting them like that with each other will describe the perfect circle. So I've already done this thing here. Okay, that's another version of if I go to translate x and y and z, you'll see I'm doing the exact same thing here. And as a bonus, if when it's doing this, I put another expression on translate y, so ty is equals to frame. We'll see what happens. What this says is, while it's doing the circle, right, my height in space, I'm going to give it the frame number. That means as the frame increases, right, the height is going to increase while this cube is doing its circular motion. Okay, let's see what that gives us. So if you edit and I play it, it's going in a wavy manner upwards. If I make time pass slower, that means I'm going to slow down time by multiplying it by 0.2 maybe, and play. You can see it actually forms a spiral, which is amazing, right? So I'm gonna do a visualization of the path that it forms by going into the animation toolset and then visualize editable motion trail. Editable motion trail visualize gives us a visual representation of the path that is taken by our animated cube, because we selected it when we do the visualize, right? So it gives us a motion handle. Okay, then when we play that, you'll see that the cube indeed forms a spiral. So this is one of the ways to create a spiral kind of motion. What we did just now was control how fast or how slow the vertical motion happens. Now I'm asking myself how we control our functions, right? So just now, when I halve the vertical travel distance, the spiral becomes more compressed because it came down. It used to be here at 0.2. So edit. Okay, so it used to be here. So you want to travel more circles, more rounds around the z and x axis while it's going up. So the way to do it is to hasten the passage of time. So if you do 0.4, hit edit, you will see 1, 2, 3, 4, 5, 6, 7, 8. So it all has to do with how we control this function. Okay. The last form of how we can expand this is, it's quite hard to show in this example, so I'm going to go back to my pendulum example, where at frame 0 it's 0. What happens if at frame 0 I wanted to start it off at the extreme 20 degrees, for example? It's actually 30 degrees plus minus. So over here you can see that it is frame 8. So what if at 0 I wanted to start at frame 8? So what I can do is 8 plus this. Because of the multiplication and divide priority in the evaluations in mathematical expressions, you will get multiply and then plus 8, which is not what we want. We actually want to offset the frame by 8, and then we do the slow down. Okay, in this way, I'm gonna hit edit. On my frame 0, I already start with this. So I'm gonna undo this and show again how I came up with the magic number 8. So undo. In this state of the expression, I saw that I needed to get to this pose at that speed. That pose happened at frame 8. To get that, I know that at this point, this frame needed to be at 8. What I needed to do was offset whatever frame number that came in. In order for this guy to be here, the frame needed to be 8 at frame 0. Because we know that if I didn't have that bracket, I know that Maya's going to evaluate 8 times 0.2 first, and that's going to give me a nonsensical well, 8 times 0.2 times, that's going to give me 1.6, right? So the multiplication now no longer tries to slow the frame down, but it serves the purpose of making 8 a greater value plus 1.6, and then that's going to give me at frame 2 plus 1.6, which makes no sense. I'm going to hit edit, and then you'll see instead of giving it an offset, it sped up. So not what we want, okay? And even though it did start at did start at this angle, what we actually wanted is to feed in and offset the frame by 8 frames, so that at frame 0 it evaluated to frame 8, and then continue on from there, right? Get that frame offset already, and then do whatever we had before, multiply by and slow that frame down. Alright, with this I edit, I rewind, and then I play. You'll see the exact same animation, okay, with a multiplier to slow time down, but the frame has been offsetted, and then we multiply it by 30. So you see the form has evolved again. We can say that the frame is offset, right? Plus an offset times speed multiplier, and then this is a amplitude multiplier. Okay, so that's the current form. But what happens if I didn't want the center of the swing to be centered at 0? Okay, what if I wanted the swing to be swinging here? So what do I have to do? This rotate Z is an angle, right? If we want to shift this animation so that it happens here, it's a 90 degree, right? So from here, now it's going here, it's centered along 0, going downwards. What I have to do is offset this entire animation by 90. So I'm going to do 90, it's negative 90. Okay, so when I play it, you'll see it's centered around the center axis of this line that we cannot see, but it's going to and fro from the center line. So what happened? You'll be able to see it here, okay? Before we did that, okay, negative 0. I zero it and I hit edit. This is happening between negative 30 and positive 30. When it swings between negative and 30 and positive 30, the amplitude is 60 degrees. So plus minus 60 degree, right? When we added that negative 90, I shifted down the whole curve by 90 units. Edit, you'll see the exact same curve. I shifted 90 units down because it is in rotation, it's 90 degrees, okay? Our form has further evolved, and it's called the plus this. Because it's a plus or a minus, we can do the offset behind as well. But that doesn't seem very intuitive to me, because you got the sign and then you multiply, then we know that multiply has precedence, has priority, so that's going to get multiplied, and then we apply our offset, which is correct. But somehow it's a personal preference. Okay, you can totally do this, it will be exactly the same. Minus 90, and then I hit edit. You'll still see do the exact same thing, because you have like times 30 minus 90, two constant numbers side by side. It just looks a little bit confusing to me, right? So for clarity of layout, you'll see that this number and then plus this function, to me it's like, oh, you shift it first, and then right, whatever this value gives you gets shifted. I'm gonna put it like that for now. That is the general form in my mind. As I need it, I add more things to it, as long as we know what's driving it and how it works. So that's the speed of the time, the x-axis, okay, and then the value that it gives you is the evaluation. So it evaluates that, gives you the value. If the value is too small, the amplitude is too small, you multiply it. Okay. When it's not in the range of the value you want, you offset it and transpose it and shift it to a new range of values. That's all there is. Okay, so now I'm going to show you a few more examples that I set up. I've mentioned in previous videos that everything inside Maya is driven by values. Because we're dealing with values, and because we have a way now to create oscillating, predictable, wavy sine and cosine, we can drive anything. So here I got two spheres, and right. So what I'm doing here is driving the color with a blend. So the blend mixes two colors, and then it chooses between those colors. So I have color 1 and color 2, and then the other one is actually taking the opposite color, whatever this color is. So I'm driving it by an expression. So sine. So that expression goes from 0 to 1, and when it goes to 0, it chooses the red color. When it goes to 1, it chooses the blue color, and then it's just alternating between these. Okay, and it forms a smooth transition. Okay, and what the other one does, so the other one takes 1 minus that color, so it takes on the other color. So if one is absolute red, the other one is the color 2, which is blue. Okay, so that's that. The other one, it would be it's a bit more interesting, I think. This a little bit more elaborate in the setup, where I drive the scale of each cube. So I have like 8 or 12 cubes. So each cube is offsetted. Each cube has an offset. So I started to do variables. Each cube has an ID, offset variable, where I offset the frame. Maybe in another video I might talk about that. Okay, so y. So the ID has been increased to 1. The next one, scale y, the ID is now 2. And then scale y, the ID is now 3, and the offset always remains the same. ID is 4, so only that ID for each block is increasing, and by that, at any frame, these blocks are offsetted from each other. Therefore, we get to see the movement, and we actually get to see the sine wave. Okay, because frame is incrementing, right? The frame is increasing, and then each one of them at any time is offsetted. So the ID, it knows I am cube number n, and then the ID keeps increasing, but the formula and the speed remains the same for all of them. That's all I have for you. I might in another video talk about more advanced use of combining, like I mentioned, values to make more organic, because our eyes are very good at picking up regular patterns that repeats itself or form a perfect arc. It's easy to see, and we do catch perfect things, perfect motion. So in CG we want to break that, right? We want to have more organic motion. I might think about how to show that in a later video. Right, thanks for watching. I'll see you next time.